So lesson 11.3 is on simplifying rational expressions. And so I just want to quickly go over the fact that rational expressions, they are expressions that have fractions in them. So a rational number is a number that can be written as a fraction. So a rational expression is a fraction with polynomials. Technically, it could be a monomial. Essentially, it's saying it's a fraction with variables. Okay. The reminder with that is we do have a denominator that can never equal 0. So that leads to excluded values, which we did already. And when they go to graph, they become vertical asymptotes. Our goal for today is twofold, okay? Not necessarily in any order, but we have two goals. So we want to be able to write expressions in simplest form. And then we also want to include, or state actually, excluded values. And these could be at the beginning or end, or in the middle. Beginning, middle, or end of the problem. So it's not necessarily one or the other, it's if it shows up at all. Okay. All right, and so let's do our first example. So if we have, we have 12x to the third y squared over 2x squared y to the fifth, we want to be able to simplify this. And because it's a monomial over a monomial, I can just kind of group together and say, well, 12 and 2 can simplify. X squared and x cubed can simplify, and y squared and y to the fifth can simplify. I'm going to go ahead and expand it out the long way just so that you can see how these could be reduced this way. So 12 and 2 I'm going to leave because we know how to simplify those. But x cubed is x times x times x. X squared is x times x. Y squared is 2y's. And y to the fifth, we have 5y's, okay? So all of, most of these will end up canceling, okay? So 12 and 2 can reduce by 2 to give us 1 and 6. So that's going to be 6 divided by 1 is just 6. I don't necessarily need to write this one. X divided by x is 1, x divided by x is 1, and I'm left with an x on top. Y divided by y is 1. Y divided by y is 1. I'm left with 3 y's on the bottom. And that's y times y times y, which is y cubed. So I don't necessarily need that long of a bar. So this is my simplest form. And then I do want to list any excluded values. So x cannot be something and y cannot be something based off of my beginning. So x cannot be 0 and y cannot be 0 because that would make my denominator 0. So both of those are excluded values. So I have my simplest form and I listed what it cannot be. So my next problem is going to be n over n plus 8. Now, in the last problem we had monomial over monomial, so we can just simplify because each one of the things I highlighted are called factors, okay? Here, we don't have two factors. We have an n and we have an n plus 8. So this is one number, and this is one number, but there's nothing multiplying both top and bottom. And unless the parts in the parentheses are identical, I cannot cancel them. So my simplest form is actually the original, so it's just going to stay. And then I'm just going to include my excluded value is negative 8 because that would make my denominator 0. So it's important to remember that when we have polynomials, Most of the time we want to try to factor them, okay? And then they need to be identical in order to cancel. And think of it as grouping. So parentheses around anything that's adding or subtracting, and what's inside the parentheses must be identical. So let's try, we have 3a squared over 6a times a minus 7. Okay, and so this is a factor, and this is a factor. So in order to cancel anything, I need to see if I have something that's the same. So we have 3 and 6 are both factors, okay? And so they can reduce by 3 to give us 2 and 1, okay? A squared is the same as a times a. Divided by a, that reduces, and I only have one a on top. I have a 2 on the bottom, and then a minus 7 cannot simplify because I don't have anything else identical to it. So this is going to be my simplest form. And then I just need to include that a cannot be both 0 or 7. Okay, so for my next example, we have 1 minus z squared over z minus 1. Okay, now again, in order for polynomials to factor, they have to be identical. Okay, and they need to actually be factors. So right now I don't have any factors. I can factor this top. It is differences of 2 squares, but since my denominator has the z first, I'm going to actually rewrite the top by factoring out a negative 1 so that they flip, and so that the z squared is now positive and the 1 is now negative. And you'll see why that helps in just a second. So I can factor this a little bit further so that it's, I need 2 numbers that multiply to negative 1 and add to 0 because there's no middle term. So we have z plus 1 and z minus 1 all over z minus 1. And then when I look at my problem, z minus 1 is identical to z minus 1 down here. So now I actually can cancel my denominator. And then I can distribute this back out to get negative z minus 1. So that's going to be my final answer. But, we need our excluded value. Z cannot be 1. Okay, number 5, we have c squared plus c minus 12 over c squared minus c minus 20. Okay, and again, because I'm adding and subtracting, I cannot group things saying, let's just cancel the c squared. That's not the way it works. We have to group them. So until we factor them, these are grouped by themselves, okay? Now, luckily, they do both factor, and I need numbers that multiply to negative 12 and add to 1. So that's going to be positive 4 and negative 3, and that will be c and c. And then I need numbers that multiply to negative 20 and add to negative 1. So that's going to be negative 5 and positive 4, and again, c and c. So now let's look and see if I have anything that's identical. C plus 4 and c plus 4. They're multiplying, which that allows me to cancel them. I'm left with c minus 3 and c minus 5. My excluded values are 5 and also negative 4. Okay. My last problem is going to be an example of surface area compared to volume. And we are going to have a rectangular prism. Draw it as best I can. And each of these sides down below are going to be x, x, and 2x. So this base is actually a square because we have x times x. And the area is going to be the same top and bottom. So my surface area for this is x squared, and I have 2 of them, so it's going to be 2 times x squared. Now, the sides, because my bases are the same, this side on the left, on the front, on the other side, and on the back, they're all going to be 4x, 2x times x, which is 2x squared, and I have 4 of them. Okay, now my volume is a little bit easier. It's just going to be 2x times x times x, so 2x times x times x. Okay, 2x times, this is going to be 2x squared. I'm going to go ahead and say that that's 4 times 2 is 8x squared. These are like terms, so I can add the 2 plus the 8 to get 10x squared. X times x times x is x cubed, so that's 2x cubed. And that simplifies to give me 10 over 2 is 5 over 1. X squared is the same as x times x. And x cubed is the same as x times x times x. 1, 1, I have 1x on the bottom. So this reduces to 5 over x. And my excluded values is just that 0. X can't be 0, which makes sense because if x was 0, then my shape wouldn't actually exist. That's it for today. Let me know if you have any questions when you're done with your homework.